All right, good morning again, students. Today we're going to go through 4 different theorems, and I'm going to try to talk less, do more. All right, so we're going to take notes on these pages, and actually we're going to start on page 276 right here, and we see an example, and we're going to do a second example. So, triangle proportionality theorem. So, proportions. What are proportions? Proportions are fractions. Ratios. That's what they are. So, um, proportions. Triangle proportional theorem. If you have two parallel lines, then where they intersect, it makes proportional lines. So, if TU is parallel to QS, then RT over TQ equals RU over RS. Okay, so let's see what that looks like in the real but fake world of geometry. Actually, it's a real world, really, students. It's real. So let's say we have R S T U Q, and then let's say we have some side lengths. Let's say the side length is 6. Let's say the side length is 4 and 3. And the question is what is, or just RQ equals what? What does RQ equal? So the length of RQ. Well, we learned from this proportion that if we do this over this, it equals this over this. So this is our unknown, so we're just going to call it X because that's easiest. And so we're going to go 6 over 4 equals X over 3. 6 over 4 equals X over 3. So I heard some of you calling this the butterfly or cross multiply or whatever you want to call it. Butterfly, that's kind of cute. So we have 4 times X equals 3 times 6. And then what do? We divide both sides by 4. We get X equals 18 divided by 4 is 4.5. X equals 4.5. So we just found out this value because of the triangle proportionality theorem. We found out that this length right here is 4.5. Okay, there's one. Number 2, converse. Yeah, we already know converse is the same thing, just backwards. So I'm good with that. So let's roll on over here to this crazy one. 3 parallel lines theorem. What? Seriously? Okay. No, really. It's actually, it's not that difficult. If you have 3 parallel lines and 2 transversals, then you get, they divide the transversals proportionally. So what you have is UW over WU equals VX over XZ. Well, how does that play out in the real world? Let's draw it. So I'm going to tell you that these 3 lines are parallel. So I'm taking this and I'm moving it. It doesn't really matter what this is. It just shows us we have 3 parallel lines. So now my parallel lines are going this way. I'm going to have 2 transversals. These transversals are not parallel, right? So I'm going to have F, G, H, E, D, C. And the givens, we have 3, this CD is 300. DE is 150, FG is 120, and GH is, I don't know, that's what we have to find out. So let's find out what GH is. How do we do it? Well, we know that these are proportional. ED over DC is proportional to FG over GH. So let's write that out. 150 over 300 is equal to 120 over X. This is our unknown X. So I do my butterfly, where I have 150 X equals 120 times 300. 120 times 300, and I have 36,000. Then I divide both sides by 150. I have X equals 36,000 divided by 150, and I get 240. So this length right here is 240. And if you look at it, that makes sense, right? 150 is half of 300, or 300 twice 150, so 120. So this would be twice of that, 240. X equals 240. So that's our example played out. All right, last one. This one's kind of interesting. We have our triangle angle bisector theorem. So if you have an angle bisector, meaning that these two angles are the same, right? Because this ray CD bisects this angle, makes two exact angles, exactly the same angles or congruent angles. So it divides the opposite segments whose lengths are proportional to the lengths of the other two sides. So AD over DB equals AC over CB. So what does that look like? Well, let's check it out. I'm actually going to show you really fast how to make a perfect angle bisector. So if you get yourself a compass. Oh gosh, please stay in one place. So I've got this compass. I made my line. I'm going to put my compass where I intersected. I'm going to use the same arc and make a bit of an arc, and then go to that point, make another bit of an arc. So at that point where the two arcs cross, that is my angle bisector. So this right here, I actually just made an exact angle bisector. So that's how you make an angle bisector. And let's label this thing. Let's see, we'll say this side length is 24. We'll say this side length is 14. This one's unknown, and this one is 48. So how are we going to find out what X is with only these numbers? Well, we know this is a bisector, so we can use our triangle angle bisector theorem. And we know that AD over DB, so 14 over X, equals CA over CB, 24 over 48. All right, and we do our little butterfly, cross multiply, so we have 40, we have 24x equals 48 times 14. 48 times 14, 672. And I divide both sides by 24. And I get 28. So x equals 28. So this side right here is 28. Perfect. There you go. That's how you use those theorems to solve problems. Your homework is going to be numbers 1 through 9 on page 277 and 278. And let me know if you have any questions. questions.